Alright, so arithmetic with complex numbers. We're going to look for like terms, and since I is the square root of -1, it's basically like a radical, so we treat it like the same way you would in x as far as combining like terms. So those are like terms, and those are like terms. We're going to, the i's are like terms, and the numbers are like terms, but on this one we have the negative, so we got to distribute that first. So let's go back and look at the first one here. We add the real numbers and add the imaginary numbers, and that's it. We're done there. This next one, we got to distribute the negative. Then we add the real numbers and add the imaginary numbers. That is our final answer. So remember that I squared is -1. So when we multiply these, we multiply the real numbers. 3 times 4 is 12, and I times I is I squared. So that's really like -12 times a -1, which gives us a positive 12. Also recall that square root of -1 equals I. So anytime you have the square root of a negative like we do here, what you're going to do is immediately pull your i's out. Alright, you're going to write root -3 as I root 3, and root -15 as I root 15. So then you do the I times I is I squared. We factorize the 15, so I have a 3 times 3 times 5 underneath. So at 3 comes out, the I squared is really equal to a -1, which gives me -1 times 3 root 5, which is -3 root 5. So here we multiply all the numbers, multiply the i's, get I cubed, which you recall is really equal to -I. So we have -30 times -I, which is equal to 30i. Alright, if we're multiplying complex numbers like so, you're just going to distribute or FOIL them out. So 2 times both of those, and the -5 times both of those. Now we combine like terms, or recalling that I squared is a -1, so that -10 is really like, -10I squared is really like a positive 10. So now we combine like terms. 10 minus 8 is 2. 4 plus 20 is 24i. Same thing on the next one. Now you'll notice that when we do this, we still got the I squared thing. So I squared times -16 is like a positive 16. But we have equal and opposite middle terms, so those cancel out. So it's just 9 plus 16.
The man of the mathematics department.
Alright, thank you, Mr. Caplow. So notice there is no imaginary part after this. So these two numbers are similar but different, changed only by the sign in the middle. These are called complex conjugates. So for the next example, what we're going to have to do is multiply by the complex conjugate. So of the bottom, of the denominator. So 2 plus 3, its complex conjugate is 2 minus 3i. So now we got to treat those like two foiling problems. We foil the top, and we foil the bottom. We recall that every I squared is really equal to a -1. So that's 4 plus 9 on the bottom. And then the top simplifies to 3 minus 11i. So we get 3 minus 11i over 13, or you can write them both over 13 and have 3 over 13 minus 11 over 13i.